Howdy! In this problem, we're going to complete the square to show that this equation represents a circle. So this equation is in fully expanded, sometimes it's called general form of a circle. Equations of ellipses and hyperbolas look pretty similar to this, by the way, but this one does turn out to be a circle. All right, so how do we do that? Well, what I'm going to do is put just for a minute, I'm going to put the constant on the other side, kind of gets it out of the way for one. So, and I'm going to regroup my x's and my y's. So I'm going to start with x squared, but then next I'm going to write the plus 2x. We're going to leave a little gap there. We'll fill that in just a minute. Then we have y squared minus 6y. Leave a little gap there. And that equals to negative 7 when we subtract 7 from both sides. All right, so we're going to complete the square. So what I'm going to do, there's different ways to do that. What I'm going to do is just take the coefficient of x, divide that by 2 and square it. So 2 divided by 2, scratch work here, 2 divided by 2 is 1. 1 squared is 1, so we're going to add 1. But you can't just add 1 to an equation just because you feel like it unless you also add 1 to the other side. And then we do the same thing with the y's. Negative 6 over 2 is negative 3. Negative 3 squared is 9. So we're going to add 9. But whatever we do to one side, we must also do to the other side. So the way you get that number is you divide it by 2. You take the number in front of the x, divide that by 2, and then square it. I'm going to erase that scratch work to make some room for my next step here, though. Okay. So from here, we're gonna group together the x's and group together the y's. And then when you factor that first group, x squared plus 2x plus 1, it will factor into a perfect square, right? That'll factor into x plus 1 all squared. There we go, x plus 1 all squared, right? Because x plus 1 times x plus 1 foils out into this, right? The reason you can see that we took the b coefficient of x divided by 2 and square it is because you're unfoiling. The dividing by 2 is because the outer and inner terms are there twice, right? When you foil that out. And then we do the same thing here. We have plus that y squared minus 6y plus 9 will also factor into perfect square. Here's a tip. If you're having trouble figuring out how to factor, it's always b over 2. 2 divided by 2 is 1. Negative 6 divided by 2 is negative 3. You take b over 2 and then square it. It's what you get when you do the b over 2. But before you square it. So there's those factors. And then on the right side of the equation, we're just going to simplify a little bit. So the 9 plus 1 is 10, minus 7 would make 3. So there is the standard equation of the circle. And you can see from this, okay, the center is at HK, right? So the center, we change the number there, right? It's positive 1. So the center is at negative 1, comma. That number there, negative 3, would change that to positive 3. Right? And the radius, this is equal to the radius squared. So the radius is square root of 3, right? So your general form of a circle that I'm pulling from is x minus h all squared plus y minus k all squared equals r squared. So because that formula has a minus, that's why you change the sign. Minus, so we opposite the sign, right? Because x minus negative 1 would correspond to x minus h. All right, and we square root what's on the other side because the radius squared is equal to 3, so the actual radius is 3. All right, that's how we find or show that a standard equation represents a circle and find its center and radius.